Hello, my name is Grace Jordanoff, and I'm going to be presenting my app, VisionaryAlert, a computer vision algorithm for real-time detection of drowsy driving. Any driver who is driving during the evening or for extended periods of time is at risk of falling asleep behind the wheel and crashing. During recent years, with more Americans spending extra time outside or at work and more of them becoming deprived of sleep, there has been an uptick in the number of people who have reported driving while drowsy. About 37 million Americans have reported to be driving while drowsy in 1 year alone. Drowsy driving is responsible for approximately 1/4 of all fatal crashes in the US. As a solution to this problem, I would like to propose VisionaryAlert, an AI computer vision-based program that aims to wake the driver up with an electronic alarm whenever it senses they are showing one of the signs that may indicate drowsiness: slow blinking, consistent yawning, eyes remaining shut for more than 3 seconds, and a drooping head. VisionaryAlert uses a computer vision algorithm called MediaPipe in the Python programming language for detecting all of the facial poses. It processes visual data detected by the camera on a frames per second basis, the image of the user from the camera, and uses a CNN model to detect the coordinates of different facial features such as the ears, mouth, and eyes. The algorithm then analyzes the coordinates of the different facial features over each of the intervals recorded by the camera and detects changes within them. Certain sequences of changes within values of coordinates of different facial features can indicate certain poses that the user may depict that could indicate drowsy driving. MediaPipe requires the use of another Python library called CV2 for getting hold of the visual data from the camera for processing the image into a form that MediaPipe can analyze. A library called SciPy is also used for performing the calculations for evaluating the distances between each of the coordinates detected by the MediaPipe framework. For analyzing data for detection accuracy, I will be using the graphing libraries of Seaborn and Matplotlib. Here is the architecture of a convolutional neural network, or a CNN model. And here's a visual representation of the coordinates that MediaPipe may detect on a person's face. For this project, I will use the Python programming language and MediaPipe to create a computer vision-based app that can detect the poses that a driver may depict when they are falling asleep. I will test out my app in different settings, such as different lighting settings and different distances from the camera, to mimic the different kinds of environments drivers may experience while using the app. I will determine the accuracy of the detected poses from MediaPipe using a percentage of correct key points and bounding box localization. I will compare the average and median performances of the different poses in each of these settings. I will also do analysis on the results and record a number of true positives, true negatives, false positives, and false negatives for each of the poses in the different settings and record any trends that I may see in the data. VisionaryAlert scans for slow blinking by counting a number of times that the eye aspect ratio falls below 0.18. VisionaryAlert scans for closed eyes by timing how long the eye aspect ratio remains below 0.18 for. VisionaryAlert senses consistent yawning by checking the coordinates of the mouth to sense whether the mouth aspect ratio falls below 0.4. And VisionaryAlert scans for head drooping by detecting the angle of the ears. Here is VisionaryAlert in action. light setting, VisionaryAlert for all poses had a median accuracy of 75% and an average accuracy of 85%. The most accurately detected pose was the slow blinking pose, and the least accurately detected pose was the consistent yawning pose. In the regular light setting, my app has achieved a 92% accuracy rate for the slow blinking pose. The eyes being closed for a long time pose has achieved an 86% accuracy rating. The head drooping pose achieved a 79% accuracy rate. And the consistent yawning has achieved a 76% accuracy rating. The average true negative to false positive ratio is 7 to 1.5. For the bright setting, when I have tried outperforming 10 poses that were accurate and 10 poses that were similar, but not the same as the real poses, the most false positive detections for any pose was 2, and the most false negatives was 5. Here are the results for each of the poses in the bright setting graphed. In the dim setting, VisionaryAlert for all poses had a median accuracy of 65% and an average accuracy of 55%. The most accurately detected pose was the slow blinking pose, and the least accurately detected pose remained the consistent yawning. In the dimmer light setting, my app has achieved a 72% accuracy rate for the slow blinking pose. The eyes remaining closed for a long time pose has achieved a 67% accuracy rate. The head drooping pose has achieved a 62% accuracy rate, and the consistent yawning pose has achieved a 56% accuracy rating. When I tried outperforming 10 poses that were accurate and 10 poses that were similar but not the same as the real poses, the average false positive score was 5.25 and the average false negative score was 6.25. The most false positives for any pose was 7 and the highest number of false negatives was 8. In a dim light setting, here are the accuracies of each of the poses graphed out. Different cars have different architectures and different distances that the drivers can position themselves to be from the dashboard or steering wheel of the car. I have also tested out my app at a distance double the distance that I have measured for predicting the poses in the different light settings, which is 4 feet. The original distance for the light settings was 2 feet, and I've recorded my results. At a farther distance from the camera, my app has achieved a 55% accuracy rate for the slow blinking pose. The eyes being closed for a long time pose has achieved a 53% accuracy rating. The head drooping pose has achieved a 62% accuracy rating, and a consistent yawning has achieved a 60% accuracy rating. When I tried outperforming 10 poses that were accurate and 10 poses that were similar, but not the same as the real poses, the average false positive score was 5.0, and the average false negative score was 8.5. The most false positives for any pose was 5, and the highest number of false negatives was 9. The test reported a much higher number of false negatives than any other, indicating that the main fault in this setting is a high inability to detect poses due to a much smaller area of the face that is interpretable by the program. Here are the results graphed out for each of the poses in the setting with a larger distance from the camera. In conclusion, detecting drowsy driving accurately is possible with the use of AI and computer vision. VisionaryAlert's results show that it is possible to detect 4 different poses in multiple settings with relatively high accuracy. Due to the tight space of the average car, a user will not be able to place a laptop directly in front of them to be able to use this program. They can bring with them a small laptop into their car, which they can place onto the seat next to them, and a small portable camera which they can attach to a location on their dashboard or windshield, and connect it to the laptop to be able to run this program without blocking the view in front of them. As we have seen, completely dark settings may be a challenge for VisionaryAlert or any other computer vision program alike, due to lower vibrancy of facial features detected in the camera